All right, advanced math day, here we go. We got lesson 9.3.1, systems of inequalities. So just like systems of equations, systems of inequalities is where we have two separate competing systems, two separate equations, or in this case inequalities, and we need to find the set of solutions that make both of these true. So here's what we're going to do. Let's go ahead and start by graphing them. So I'm going to go ahead and graph this one first. This one has a y-intercept of 5, so I'm going to go up 5. Let's do this one in blue. 1, 2, 3, 4, 5. So there's the y-intercept. And it looks like my slope is -1. So that means I'm going to go down 1 over 1, and so on and so forth, and keep going forever and ever till the page runs out. And I can go up 1 and backwards 1 as well. Boom. Okay, this one can be equal to, so I'm going to turn this into a solid line. All right, there's the first one. Now, if this were all that this problem was, if it didn't have the and word in there, I would have just shaded underneath it. Because for this particular inequality, everything on the line is a solution, and everything below the line is a solution because it's less than. But it's not just that one, it's a system. We have a second inequality that's competing with it. And we have to find out, where do they both have agreement? Where do they both share solutions? So this one has a y-intercept of -1. So we go down 1 right there. And then it has a slope of 2 over 3. So I'm going to use my slope triangle to go up 2 and over 1, 2, 3, up 2 and over 1, 2, 3. There we go. Or I can go down 2 and to the left 3. Now this one cannot be equal to, so that would be a dotted line. So for this particular one, all of our solutions are not on the line. So the line does not include the solutions. Now this one says that y is greater than, so that would kind of be above it. Now what we have is we have 4 separate regions, and one of those regions is where these two agree with each other. Okay, so the solution to the system has to satisfy the entire system, meaning wherever we have answers, whatever region is our answers, it has to work for both of these. Name a point that could be tested to test the solution of the system. Well, 0, 0 is probably a great one. So if I've got 0 is less than 5, yes, that works. Is 0 greater than -1? Yes, that works. So it looks like 0, 0 is a solution for both of them. So whatever region 0, 0 is in would be a region for all these. So that's one way that we can do it. We can just test them. The other way that we can do this is we could name all of our regions. Like I could say, oh, you guys up here, you're region A. Or I could number them. Or I've even seen people do Roman numerals, or name them their favorite cats or something, whatever. It doesn't matter. We're just giving them some type of name so we can refer to it. So this region up here is region A. This region over here is region B. This region here is region C. That was supposed to be D. And then this one's going to be D over here. Well, let's look at our first one. That was the blue one right here. This one says y is less than. So which two regions are less than? Well, down here, there's where we would have shaded D and C. So D works for that region, and C works for that one. Let's go to the next one, the red one. This one says y is greater than. Well, which two regions are greater than? These two up here are greater than. So A and D. Now the solution to the system has to satisfy the entire system, meaning that whatever solutions we have has to work for both. Only D works for both. So this region must be the region where my solutions are. And we can test that with 0, 0, which we did earlier. 0, 0 is in that region, and it works for both inequalities. All right, so the system, name a point that could be used to test the solution. 0, 0 is a great point for that one. How do we know if the shaded region is the only region that includes the solution? That's a good question. We would check a point in each of the other ones. If I checked a point in this region, it would work for this one, but not for this one. If I checked a point from region B, it wouldn't work for either of them. See, because this one's DC and this one's AD. If I chose region A, it would only work for this one, but not this one. D is the only region that works for both of them. So our systems have to work for both of them. So how do we know that it only includes that region? We could test points in the other regions, in the other 3 regions. All right, next one. We're going to solve a system now that we know how to do it. So here we go. Oh, 10, seriously? Who does that? All right, so do I have enough for 10? Yeah, I have enough for 10. Okay. Here we go. I'm going to have to leave enough room to get up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, it works. So I'm going to put my y-axis down here. All right, first one. Y-intercept is 2, so I'm going to go up 2. The slope is 1, so I'm going to go up 1 over 1, up 1 over 1, so on and so forth. There we go. So this one's going to be dotted because it has to be less than, or because it can't be equal to. It's only less than. Okay, so this is the boundary for the first one. And our answers are not on the boundary. Doesn't work on that dotted line. This one says less than, so below that line is going to work for just that one. We have to find the region that works for both of them. Now the other one is kind of out of order. The negative 3/4 x is the negative 3/4 is our slope, and 10 would be our y-intercept. So we're going to go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the slope is negative 3 over 4, so we use our slope triangle and go down 1, 2, 3, and over 1, 2, 3, 4. I think that's all I can do. All right, this one can be equal to, so we're talking about a solid line this time. Okay, so solid line, boom, got it. All right, so for this particular one, points on the line are solutions. So this point here, 0, 10, that's a solution. It works. But it has to work for both of them. So, like I did before, I like to just name them A, B, C, and D. It doesn't matter if the top one's A or not. These are just for reference. So I'll call this one A this time, just so you think I don't have to do it a certain way. All right, A, B, C, and D. The blue one was first. It says less than. Down here is less than. A and B are the regions that are less than. So A and B work for that one. Look at the other one. This one's also less than. Less than on this one are these two, C and B. The only region that works for both of them is B. So B is the region that we would shade in. If I was smart, I would have found a purple pen. And then it'd be like red and blue made purple. See, that would be pretty smart. I didn't do that. All right, there's my region. Can I test it? Yes, 0, 0's in that region. Let's see if it works. Is 0 less than 2? Yes, it is. Is 0 less than or equal to 10? Yes, it is. So that is our region that works for both of them. All right. Now here we have inequalities, and the first one is exponential, the second one is linear. All right, so how many regions are there on this one? There's a little, let's see, I think there's 5. We'll call this one A, this little boop right there. This whole big region out here I'll just call B. I got a little region right here I'll call C. I got this whole region out here, I'll call that D. And then we get a 5th region right inside here. So I got 5 separate regions on that one. Okay, we can test all 5 regions if you want to. Or, what I prefer, is just to find the regions that work for the inequality. So, the exponential one, less than. Okay, here's my inequality. Less than is below it. So C is below it over here, D is below it, and A is also below it. So the 3 that work for that one are A, D, and C. Okay, let's look at the line. The line says greater than. So here's the line. Let's use my ruler here. Here's my line. Greater than is above that one. That would be A, B, and C. Now, what do they have in common? Well, they both have A. That's not all they have in common. They also have C in common. So this section up here is part of our solution set, and this section down here is part of our solution set. They're both solutions. And we can plug in numbers to check and see if it works. Like if I plugged in 10, negative 10, it would work for both of them. I don't really feel like doing that because I don't want to do 0.5 to the 10. But if we plug it in, we can see that it works. We're going to skip this because I don't feel like doing all the work right now. Maybe I'll do it with my class. All right, why is 0, 0 not a good number to test on this one? 0, 0 is right here. It's a horrible number to test because it's on this line. We don't want to test points on the line. We want to test points in a region. So it's on a line. And we want to test regions. All right, next page. We've got pretty much the same exact inequality here, but this time we switched around the arrows here, or the inequality symbols, a little bit on each of them. So it's the same exact ones, so let's just go ahead and label it the same. This one we're going to do A, B, C, D, and E in the middle here. Okay, so greater than this curve. Greater than this curve would be E and B. Those are the 2 that are greater than. So E and B. Greater than the line. Well, here's my line. Greater than would be A, B, and C. Now, in this time, there's only one region that works for both of them, B. So I can't go over into this section because that's region A. So I'm going to go all the way down along this line. I can't go over down here because that's C. So it would be this region here. And there's the region where I would find solutions. So I might plug in like 1, 1. 1, 1 is somewhere like around there. And we can check and see if it's a solution for it. And it is. Next one. Again, we'll just label them A, B, C, D, and E. Looking at the exponential function, it says greater than. Okay, so let's just look at greater than. So here's my function. Greater than is this section here. That's E and B. Okay, so E and B is greater than. Next, this one says less than, so that's underneath the line. So here's the line. What's underneath it? E and D are beneath that line. So they share a section, and it's only section E. So here we would only get answers inside of here. Those are the only answers that we could get to work. And maybe -1, -1 would be a number inside there. So we might check out -1, -1. And by the way, it works. All right. For this one, A, B, C, D, E. Those are my regions. All right, so this one says less than this curve here. So less than the curve, that's these ones here. A, D, and C are less than that curve. See that? Here's A, D, and C. Those are all the ones that are below that curve. So A, D, and C. For the other one, it's less than the line. So here's my line. The only two that are less than that line are D and E. So the only one they have in common is region D. So we would shade this section here, make sure not to go into region E. So go around that region there. All right, there's our region. So we might test -10, -10, because that's definitely in that region over there. And -10, -10 would work for both of those inequalities. All right, last one. The United Nations asks every nation to write constraints that best approximate its country's shape. Maybe they want to find the area of the country or whatever, who knows. Honduras sent its constraints, but some of the information is missing. Come on, Honduras. What are you thinking? So anyways, we have to determine the missing parts and finish the inequalities. All right, so it looks like this first one is missing the inequality sign. So this is x plus 3. So which one has a y-intercept of 3? Looks like this one, and yeah, it does look like it's going up 1 over 1. So it looks like it's that one. So if I'm looking at this, it looks like we're shading underneath that one. So we're going to say less than or equal to for that one. Okay, next one says y is greater than or equal to 1/2 x minus, and then we have something here. So that should be the y-intercept, right? So I need something that has a y-intercept that's a negative. So this is my negative y-intercept. Now, which one has a slope of 1 over 2? It has to be this line right here. So it's greater than, so we're above that. So that makes sense. So it looks like here's greater than that line. So this one has to have a y-intercept, what's that, -1? Yeah, it has to have y-intercept of -1. Y blank 2. So that should be a horizontal line. Here's y equals 2 right here. But we're shading below that line. So that would be less than or equal to. This one, -2/3 x plus 4. So this is the only one with a y-intercept of 4. And it's going down 2 over 3, down 1. Oh, down 2 over 3. Okay, something like that. So, oh, these are in 3s. No, they're not. Down 2, so down 1, 2 over 3. Okay, yeah, so that's that one. So that's this one up here. And it's underneath that line. See right here, here's the line, and we're shading underneath it. This region's underneath it. So that's going to be less than or equal to. Last one, we've got -1 as the intercept, and it's got a negative slope. So this is this line right here. And on this line down here, we're shading above it. So that's greater than or equal to. The end. Math hard, my friends. I'll see you later. Bye-bye.